Welcome to Jamb Physics revision class. In this class, we're going to go over past exam questions on the topic scalar and vector quantity, dimensions, and measurements. Okay. The international agreed system of units for physical measurements are A, pounds, feet, and seconds. B, gram, meter, and seconds. C, kilogram, meter, seconds. D, centimeter, gram, and seconds. E, kilogram, centimeter, and seconds. Don't forget that the basic units that we have are kilogram, meter, and seconds. Are you getting it? This is it. Kilogram, meter, and seconds. And the right option to that question is option C. The first option was disqualified because of the presence of pounds and feet. They are not international agreed system units, you understand? And also the second option contains gram. Are you getting it? It contains gram. So the presence of gram instead of kilogram disqualified that one. And if you look at the third option, it has centimeter and gram. So that cannot be called international agreed system unit. Why the fifth option, which is kilogram, centimeter, and seconds, also was disqualified because of the presence of centimeter. Do you understand? Okay, let's look at the second question. To determine the weight of an object, you could use A, use a beam balance. B, use a spring balance. C, find the force necessary to give it a certain acceleration. D, use none of these methods. E, use any of these methods. Okay, now let us examine each options. Are you getting it? Now, the first option says use a beam balance. You know, a typical example, let me just draw it on the board. You see this? Look at this diagram. In fact, just look at the diagram that you can see on your screen. That diagram here, it works on the principle that it measures the mass of the unknown object using the mass of the known object. You understand? It is an instrument that is used to determine the weight of an object using the mass of a known object. Do you understand? So that first option is used to measure the weight of an object. And if you check the use of a spring balance, you've seen, just check the screen. That diagram that you see there is used to measure the weight of an object, and that will depend on the strength, how far the object can stretch the spring. You understand? How far the weight of the object stretches or compresses the string. That is how it works. Are you getting what I'm trying to say? And if you look at the third option, finding the force necessary to give it an acceleration, you know that force equals to mass times acceleration, right? And if you know the acceleration of an object, you can easily determine the mass. You understand? And if this acceleration is acceleration due to gravity, that means that the force here will be what? Will be weight force. And that means it is also a kind of another method of determining the weight of an object. Also, you can see option D, use none of this method. That is not correct, because option A, option B, and option C can be used to find the weight of an object. And option E, use any of this method. That is the correct option. Okay, the correct option is option E, because you can use any of the option A, you can use option B, you can use option C. Do you understand? Okay, so let's look at the third question. The first option, the correct answer is the correct option is option C. Okay, and the second as well, the correct option is option E. Why the third? We are in the third question now. Which of the following physical quantities is not a vector quantities? Okay, a vector has both magnitude and direction. You understand? That is, you can measure it and also you can know the direction. I get what I'm trying to say. So let us look at the option there. We have velocity. Velocity simply means displacement. Velocity equals to displacement all over time, right? And displacement means the distance that which an object travels in a particular direction, and the time here is in seconds. Are you getting it? So that is what? Meter per seconds. So this is a vector quantity. Do you understand? We are asked to determine the quantities among the option that is not a vector. Do you understand? So velocity is a vector quantity. Now let us check the work. Work equals to product of force and distance, right? Force times distance will give us work. or force times displacement, it will give us work. Now, do you know that force is a vector quantity? Are you getting it? Force equals to what? MA. Mass times acceleration will give us force, right? And this displacement is also what? A vector quantity. Now, anytime you take the dot product of a vector of two vector quantities, you're going to have a scalar quantity. Do you understand? I'm going to take that again. Anytime you take the dot product of two vector quantities, you're going to have a scalar quantity. Do you understand? So the product of force and displacement, which give us work, will give us a scalar quantity. Do you understand? So work is a scalar quantity. Scalar. This is a vector quantity, and this is a scalar quantity. Now look at the third option. I'm examining all the options. Do you understand? So I'm not actually interested in the answer alone. You must know the reason why other options are not correct. Do you understand? So that's what I'm doing, okay? Now, force work is not a vector quantity. Force is a vector quantity because it is the product of mass and acceleration. Are you getting it? And acceleration is change in velocity over time. And velocity is also what? A vector quantity. Force is a vector quantity because it has magnitude. That is the weight, the mass, the size of the object. How heavier the mass of the object, you understand? And also it has acceleration. Acceleration means the velocity travels by an object in a particular direction with respect to the time taken. Are you get what I'm trying to say? So that is it. And also we have electric field intensity. That is also what? A vector quantity. Electric field intensity. Magnetic induction or magnetic field is also a vector quantity. The only option that is not a vector quantity is work. Do you understand? Okay, now let us look at the next question. An example of a scalar quantity is dash. A, velocity. B, weight. C, electric charge. D, acceleration due to gravity. E, momentum. That is question 4. Question 4. Example of a scalar quantity. A scalar quantity only has magnitude, but there is no direction. Do you understand? So both scalar and vector quantity are interwoven. It's just that the opposite of scalar quantity is vector quantity. Do you understand? An example of a scalar quantity is A, velocity. B, weight. C, electric charge. D, acceleration due to gravity. And E, momentum. A scalar quantity is a quantity that has only magnitude but no direction. Do you understand? Okay, now look at the first option, which is velocity. Velocity is a scalar quantity. For example, you can say that a motorist traveled 65 km per hour northeast. Velocity example, 65 km per hour northeast. Now, this is the direction which the motorist is traveling. You understand? So, and the 65 km per hour is the speed. You understand? And the reason why I'm emphasizing on this is because the magnitude is actually 65. You understand? So it has magnitude and also direction. Are you getting it? So this cannot be regarded as what? A scalar quantity. Now let's look at the second option. We have weight. Weight is equals to mass times acceleration due to gravity. Is that not it? Now, the acceleration due to gravity here makes this a vector quantity. Do you know why? Gravity is the kind of force that makes an object that goes up to come down. You understand? And when that object is coming down, it's moved to the center of the head. You understand? Are you getting it? So that means weight is also what? A vector quantity. Okay. What of the next option, which is electric charge? Electric charge is a scalar quantity. Are you getting it? A typical example is this. A typical example is plus 5c or plus 10c. This only has magnitude, which is what? Are you getting it? Which is positive 5. It has no direction. So this is a typical example of a scalar quantity. Now, look at the next option there. We have acceleration due to gravity. Acceleration due to gravity is the kind of acceleration that pull an object towards the center of the head. You understand? So that is not a scalar quantity as well. And momentum is the product. Okay, I'm coming. Momentum is equals to the product of mass and velocity. Do you understand? So now listen to me carefully. Velocity is what? Is a vector quantity. So momentum is what? A vector quantity. Is a vector quantity. Remember that here we have work. Work is equals to what? Force times distance, right? Now, force is a vector quantity. Distance. This kind of distance has direction, so we can call it displacement. Do you understand? So now displacement here is also a vector quantity. Anytime you take the dot product of two vector quantities, you're going to have a scalar quantity. Do you understand? So that means, but it's different from this. This is also a mass. This one is mass. You understand? Mass times velocity. So the momentum is also what? A vector quantity. The correct option to that question is option C is correct, electric charge. Okay. Now let's look at the next question. Here we have, which of the following is not a vector quantity? Are you getting it? We are asked to examine the option. Which of the option is not a vector quantity? You can see now. We have force. Do you know what you are looking for now? We are looking for a scalar quantity in this option. So now you have force. Force is a vector quantity. Do you know? Yeah. Altitude. Altitude simply means how high an object is. You understand? Altitude is the height which an object attains above the sea level. Do you understand? And we have the option C, weight. We have D, displacement. We have option E, acceleration. The correct option is option B. Option B is correct. Altitude is not a vector quantity. It is a scalar quantity because it only describes how high an object is above the sea level. Do you understand? Of the following derived units, the one that is not a unit of power is A, joule per second, B, ampere volt, C, ampere square volt, D, ohm square per volt, E, volt square per ohm. Okay, power. I'm coming. Power is equals to work all over time, right? Is that not it? Because power is the time rate of doing work. You understand? So now work is measured in what? In joule. You know? And also time is in seconds. So the first option, which is joule per second, is correct. Okay. Now let us look at the second option. We have ampere volt. Power is also written as current. Are you getting it? Multiplied by volt. Do you understand? And the unit of current is what? Is ampere. Are you getting it? And the unit of volt is V, you know. So ampere volt, just be like that. Now the third option says, from the third option we have ampere square volt. You see, power is equals to IV, you know, current multiplied by volt, right? Now, do you know that V from Ohm's law, V is equals to IR. Do you know? So if V equals to IR, you can replace V here. You're going to have I multiplied by IR. Are you getting it? So this will give me what? I square R. Now they made a mistake. They made a mistake in the question. They said ampere square volt is supposed to be ampere square ohms. Do you understand? The correct representation should be ampere square volt, ampere square ohm. Do you understand? Because this R that you see here stands for ohms. Oh, you understand? So it should be ampere square ohms. Are you getting it? It's not ampere square volt. So maybe they made a mistake. That is option C. Now, if you look at the fourth option, ohm square volt, option D, they said P equals to ohm square over volt. This is not correct. Do you know why? If V, listen to me, from here, V equals to IR, V equals to IR, right? And we know that power equals to IV. Is that not it? Power equals to IV. Now, I want to make I the subject of the formula here. What is on equation 1? What is on equation 2? I will be equals to V over R, right? So substitute the value of I into this formula. You're going to have power equals to V over R multiplied by what? V. Are you getting it? Because now I has been replaced as V over half. So I'm going to have P equals to V squared all over half. Now, listen to me carefully. If you compare this and this, you will discover that they are not equal. Do you understand? So this is not correct. Okay, option D is not correct. Are you getting it? And if you look at the last option, which is E, volt square over ohm, this is correct. Okay, volt square all over ohm. Do you understand? So that means the unit that is not the derived unit that is not of power is option D. Do you understand? Option D is the correct option. Option D is ohm square over volt, which is this. It is not correct. It's supposed to be volt square over ohms. Do you understand? Okay, so that is the answer to that question. Now let's look at the next question. Which of the underlisted quantities is the derived unit ml squared t raised to the power of minus 2? We have I, moment of a force, I, work, I, acceleration. Now, these are the options that we are given. The first option is I only. Option B, I only. Option C, I only. Option D, high and high. Option E, high and high. Okay, now, in the question, I represents moment of a force. Moment of a force. We want to check maybe the moment of a force, the dimension for the moment of a force is this. You understand? Now don't forget that moment of a force is equals to force multiplied by distance, right? Do you know? And force is equals to mass times acceleration. Is that not it? And acceleration is equals to velocity all over time. Do you understand? So now we want to get the dimension of velocity. Velocity is equals to displacement or distance that has direction. Displacement all over time. Displacement is measured in what? Is measured in length. So I'm going to have L all over T, which is equals to what? LT raised to power negative 1. Is that not it? Now, let's go back to the formula of acceleration and substitute the value of V as LT raised to power negative 1. So I'm going to have acceleration is equals to LT raised to power negative 1 all over T, right? Now, here I'm going to have acceleration is equals to LT raised to power negative 1 multiplied by T raised to power negative 1, because 1 over T will give me what? T raised to power negative 1. So the dimension of acceleration will be LT raised to power negative 2. Do you understand? Okay. Now, moment of a force. Moment will be equals to force. Instead of, please pay attention. Don't forget that force is what? Mass times acceleration. I'm going to have mass multiplied by acceleration. Acceleration now will be, the dimension of acceleration is LT raised to power negative 2. So I'm going to have LT raised to power negative 2 multiplied by the distance. Distance is also measured in what? In length. You understand? It's measured in meter, and meter is a length. You understand? I'm going to have L. So I'm going to have M times L, that is what? L squared T raised to power what? Negative 2. So that means that the moment of a force, the dimension is equals to this. Now, the second option there, I'm coming. The second option, we have work. No, not second option, high. The formula for work is equals to force times. So I'm going to have the dimension of force is what? MLT raised to power negative 2 multiplied by L, right? So that will be what? ML squared T raised to power negative 2. So you can see that it's still the same. So I is what? Is acceleration. And acceleration, the dimension of acceleration is what? LT raised to power negative 2. So I'm going to have LT raised to power negative 2. So now, if you look at the the question says, for which of the underlisted quantities is the derived unit of this? Is this derived unit? You can see that moment of a force is the derived unit. Also, work is the derived unit. So option D is correct. Do you understand? Option D is correct, okay? Now let us proceed to the next question. Which of the following is not a fundamental SI unit? A. Meter, B. Ampere, C. Kelvin, D. Second, E. Radian. Okay, the first option we have meter. Meter is measured in length, you understand? Length is measured in meter, so that is a fundamental unit. Ampere, the unit of current, electric current is ampere, so that's a fundamental unit. Kelvin, that is for temperature. Seconds is for time. So the correct option that is not a fundamental unit among our option is option E, which is radian, you understand? Option E is not a fundamental unit. Okay, the next question. Which of the following is a derived unit? A. Kilogram, B. Meter, C. Kelvin, D. Newton. Newton is the derived unit. The correct option is option D. Option D is correct. The derived unit among the options is Newton. You know, Newton is the unit for force, you understand? And force is equals to mass times acceleration, you understand? That is what? Kilogram multiplied by, now, acceleration is what? Change in velocity over time, right? So that will be kilogram meter per second squared. So this is what? Newton. Do you understand? 1 kilogram meter per second squared is what? Is Newton. Do you understand? So that is 1 Newton. So the correct option is option D. Which of the following units is equivalent to kilogram meter per seconds? A. Newton per seconds. B. Newton meter seconds. C. Newton seconds. D. Joule per seconds. Okay, we are given this unit. The unit that we're given is kilogram meter per seconds, right? Now we are given the following option: Newton per seconds. We have Newton meter seconds. We have option C, Newton seconds. We have option D, joules per seconds. Now we want to examine the following option. Which of it is equivalent to this? Are you getting it? Which of these units is equals to this? So let's start with the first one. Option A. Option A is Newton per seconds. Now, Newton is what? Newton is the unit for force, right? And force is what? Mass times acceleration. Force equals to mass times acceleration. Is that not it? And mass is measured in kilogram. Is that not it? And acceleration is what? Meter per second squared. So I'm going to have kgm. M stands for meter per second squared. Is that not it? Now, we are having Newton per seconds. The unit for Newton, force is measured in Newton, and 1 Newton is equals to kilogram meter per second squared. So here I'm going to have N over S equals to what? Kilogram meter per second squared divided by seconds. Are you getting it? This seconds is here. The unit of Newton is what? Kilogram meter per second squared. Do you understand? So here I'm going to have kilogram meter per second squared multiplied by 1 over S, right? So that will give me kilogram meter per second cube. Do you understand? Which is also the same thing as kgm s raised to power minus 3. Do you understand? So you can see that this is not equals to this. So option A is disqualified. Do you understand? Okay, let's look at option B. We have Newton meter seconds. Newton meter seconds. Now, the unit for Newton is what? Kilogram meter per second squared. So I'm going to have Newton meter seconds. That is kilogram meter per second squared. Oh, per second squared. Multiplied by meter, multiplied by what? Seconds. Is that not it? So m times m will give me what? Kgm squared. And this s, 1s will cancel this s. So I'm going to have all over s. This will give me kilogram meter per second. Okay, kilogram meter squared per seconds. Do you understand? And also, it is not equals to what? Kilogram meter per seconds. Do you understand? Kilogram meter squared per seconds is not equals to kilogram meter per second. So option B is also disqualified. Do you understand? Let me tell you the truth. If you want to know the option that is correct, you must know the reason why the other options are not correct. And that is why I'm trying to explain each option. Do you understand? Okay, so now let us look at the third option. We have Newton seconds. The third option, which is option C, Newton seconds. Newton is what? Kilogram meter per second squared, right? Multiplied by seconds. Are you getting it? NS. N stands for this. Are you getting it? So here I'm going to have kilogram meter all over S squared multiplied by S, right? So 1s here, we cancel 1s. So I'm going to have kilogram meter all over s. This is what? Kilogram meter per seconds. You can see that this option C is the unit that we have here, which is what? Kilogram meter per seconds, is equals to what? Kilogram meter per seconds, which is the same. So the correct option to this question is option C. Do you understand? Option C is correct. Let us look at the fourth option. The fourth option is joule per seconds. That is option D. Option D, joule per seconds. Joule per seconds. Joule is the unit of work done. You understand? And work done is what? Force times distance, right? Joule is the unit for work done. Work done is force times distance. So I'm going to have force. Force is what? Kilogram meter per second squared, right? So I'm going to have kilogram meter per second squared multiplied by distance. Distance is measured in meters. So I'm going to have times m. That this alone that you see here is work done, which is the unit of joule. Do you understand? Now, this second is here divided by what? S, right? So I'm going to have kgm squared all over s raised to power 3, right? Which is equals to kgm squared s raised to power negative 3. Are you getting it? You know, if this division sign change to multiplication sign, you're going to have 1 over s, right? So s 1 over s times this s will give me s cubed, right? So that's how I have this. You can see that this also is not equals to what we have here. So the only unit that is equal is Newton seconds. Do you understand? So the correct option is option C. Now you can see the reason why other options are not correct. That's how to answer objective question, especially when you are dealing with a topic of this kind. Okay, so let us look at the next question. Which of the following are correct SI units of the quantities indicated? Okay, we have I. I represents Newton, which is for force. Okay, we have II. II is Newton per meter, which is for torque. Are you getting it? Then we have III. That is watt. And that is for power. Okay. And the fourth, we have kilogram meter per second squared. And that is for momentum. Now, we are given these options. Option A, high and high only. Option B, high and high only. Option C, we have I and high V only. Then option D, we have I and high only. Now, let us examine the following. You know that Newton, force is what? Force equals to mass times acceleration, right? And the unit is what? Is in Newton. So this quantity is correct. Now, what of torque? Torque, torque is equals to force times distance. You understand? Torque is equals to force times distance. So now the unit of force is what? Newton, right? The unit of force is Newton and distance is measured in meter. So the correct unit is supposed to be Newton meter. Do you understand? So therefore, this is wrong. Are you getting it? Newton per meter is wrong. Now let us examine watts. We know that the unit of power is what? You know, power is equals to high V, which is what? Ampere multiplied by volt. Do you understand? And the unit is what? Is watt. So this is correct. Are you getting it? Now what of this? Momentum. Momentum is mass times velocity. Momentum is equals to mass times, okay, let me just write in full. Mass times velocity. And mass is in kilogram, do you know? And velocity is what? Meter per seconds. So you can see that this is also wrong because we have kilogram meter per second squared. Are you getting it? So this is also wrong. Are you getting it? The unit of momentum is kilogram meter per seconds. So the question, let's go back to the question. Which of the following are correct SI units of the quantities indicated? So you can see that force is measured in Newton. So this is correct. I is correct. I is correct. Then we have which other one is correct? Watt. High and high. Those are the quantities that their units are correct. Do you understand? So the correct option to that question is option D, which is I and high only. That is Newton and watt. force and power, their units are correct. Okay, so the correct option is option D. Okay, now let us look at the next question. Which of the following quantities are scalars? Okay, scalar quantities has only magnitude, but there is no direction. Do you understand? Okay, so we have I stand for electrical potential. Electrical potential. And I stand for torque. You understand? And also we have I, which is for momentum. You understand? Momentum. And we have the fourth, which is IV. That is kinetic energy. Kinetic energy. Now, among these, listen to me carefully. Among these, torque is a vector quantity. Vector quantity. Also, momentum is a vector quantity because both of them, they have magnitude and they also have direction. Do you understand? So, this and this are vector quantity. Now, the only the scalar quantity among these is the electric potential and kinetic energy. These are scalar quantity. Scalar, and also this one also is a scalar. So that means among all these, the scalar quantity that we have are I and IV. They are scalar quantities. Do you understand? So the correct option to that question is option D, which is I and IV. Option D is correct for this. Okay, so let us look at the next question. Okay, which of the following is a set of vector? A, force, mass and moment. B, acceleration, velocity and moment. C, mass, weight and density. D, mass, volume and density. Okay, now let us examine the options one by one. Force is a scalar, force is a vector quantity, you know, yes, but mass is not a vector quantity. Do you know? Moment is also a vector quantity, but because of the presence of mass in option A is disqualified. Do you understand? Okay, the option that we are going to choose, the quantity there, all of them must be vector. Do you understand? So option A is disqualified because of the presence of mass. Let us look at option B. We have acceleration, velocity and moment. Acceleration is a vector quantity, velocity is a vector quantity, and also moment is a vector quantity. So therefore option B is the correct option to that question. Okay, but now we are not going to ignore the rest of the option. We are going to examine it. Why are they not regarded as, what makes them not to be the appropriate option for this question? Look at option C. We have mass, weight and density. The presence of mass and density disqualify the option. Do you know that weight, especially let's look at weight force. Weight force has direction, and the direction is towards the center of the head. Do you understand? So weight is a vector quantity, but mass and density are not vector quantities. So therefore the option is disqualified. What of option D? Mass, volume and density. That cannot also be the option. Do you understand? Okay, now let us look at the next question. Which of the following is a fundamental unit? Fundamental unit. Let me give you an example. Example of fundamental unit. Example of fundamental unit. We have mass. Mass is in kilogram. Do you understand? So we have seconds. Seconds is S, and we have meter. Meter is M. We also have Kelvin, which is the unit of temperature. We also have Kelvin. That is K. You understand? So these are examples. Now we want to examine the question. Which of the following is a fundamental unit? That is, among these options, so there is only one fundamental unit. Point it out. We have option A, Newton. Option B, watt, which is the unit of power. Option C, joule, which is the unit for energy or work done. Option D, we have seconds. The correct option is option D, because that is the only fundamental unit that can be found among the option. Do you understand? Okay, let us look at the next question. Which of the following quantities has the same unit as what? A, force times time. B, force times distance. C, force times acceleration. D, force times velocity. Okay. Now, the what is the unit for power? Do you understand? Okay. What is the unit for power? And power is equals to work done, work all over time, because power is the time rate of doing work. Do you understand? And work is what? Work is force times distance, right? Work is force times distance, and time is in seconds, right? So I'm going to have T here. Now, force is measured in Newton. Are you getting it? And the unit of Newton is equals to kilogram meter per second squared. Do you understand? Kilogram meter per second squared. Force is measured in Newton, right? So I'm going to have Newton. Then distance is measured in meter. So I'm going to have Newton meter. Now time is measured in seconds. So I'm going to have S. So this is what? Newton meter per second, right? So now let us look at the options. The first option is force times time. Force multiplied by time. Now force is in what? Is in Newton. So I'm going to have Newton times time. Time is in seconds. So I'm going to have NS. This is NS. Option B, we have force times distance. Force times distance. That is Newton multiplied by Newton meter. You can see that this is not, NS is not equal to Newton meter per second. So this is disqualified. This also is disqualified. Okay. Let us look at the third option. The third option, which is option C, is force times acceleration. Force times acceleration. Now, force is in Newton. Newton times, now, the unit of acceleration is what? Meter per second squared. So I'm going to have ms minus 2, right? So that is Newton meter per second squared. What of option D? Option D is force times velocity. Force times velocity. Here, force is in Newton. Velocity is what? Meter per second. So I'm going to have multiplied by meter per second. So this is what? Newton meter per second. Okay. So you can see that this also is disqualified. Do you know why? This is Newton meter per second squared, and we are looking for the option that corresponds to Newton meter per second. So the correct option is option D. Option D is correct. Okay, which is Newton meter per second. That means that force times velocity is the right option to the question. Okay. Which of the following is the dimension of pressure? A, ml to the power of -1 t raised to the power of -2. B, mlt to the power of -2. C, ml squared t raised to the power of -3. D, ml raised to the power of -3. Okay, that's the first on our list. We have pressure. Don't forget that pressure is equals to force over area. You understand? The force per unit area is what we call pressure. And force is equals to mass times acceleration. Do you understand? Are you getting it? And because we have mass here, this would be what? Kilogram. Do you know? And acceleration is meter per second squared. So I'm going to have meter per second squared. Is that not it? So here I'm going to have kgm. Are you getting it? S raised to the power of -2. That is for force. Do you understand? This unit that you see here is for force. Now, let us look for the area. Area is equals to length times breadth. And length is what? Meter. Also, breadth is what? In meter. So I'm going to have meter times meter, which is what? Meter squared. So this will become kgm s raised to the power -2 all over m squared, right? Now, if this m comes here, I'm going to have kgm s raised to the power -2 m raised to the power of -2. Okay, law of indices. Kgm raised to the power of -1 s raised to the power of -2. Now, kilogram is a mass. You understand? The unit of mass is kilogram. So I'm going to have, which is mass. Meter is in length. So I'm going to have L raised to the power of -1. And seconds is for time. So I'm going to have T raised to the power of -2. So the dimension of pressure is ml raised to the power of -1 t raised to the power of -2. So the correct option to that question is option A. The correct answer is option A. Do you understand? Okay, so you can see how I break it down. Okay, you first remember the formula. The formula for pressure is force over area, and force is what? Mass times acceleration. Mass is measured in kilograms, so I have kilogram here. Acceleration is what? Meter per second squared. So I have this. Now area is length times breadth, and length is measured in meter. Likewise, breadth is also measured in meter. So meter times meter will give me meter squared. Okay, according to law of indices, 1 over m squared is what? M raised to the power of -2. Do you understand? And because I have one m here, another m here, m raised to the power of 1 times m raised to the power of -2 will be what? M raised to the power of 1 plus -2. Is that not it? So that will give me m raised to the power of -1. Is that not it? That is how I have -1 in this place. And because this is meter, meter is for length, kilogram is for mass, and seconds is for time. So I have this as the final result. Do you understand? Okay, let's look at the next question. The physical quantity that has the same dimensions as impulse is A, energy, B, momentum, C, surface tension, D, pressure. Okay, now impulse is equals to force multiplied by time. Do you understand? So let us first get the dimension of impulse. Do you understand? Okay, force is equals to what? Mass times acceleration, you know, and the unit is what? Newton, or kilogram meter per second square. So I'm going to have kilogram meter per second square here. And because we have time is in what? Time is in seconds. You understand? Hello? The unit of time is seconds. So here I'm going to have impulse is equals to kilogram meter per second squared multiplied by what? S. This S that you see here is for time. Do you know? And the unit of force is what? Kilogram meter per second squared. So I'm going to have kilogram meter S raised to the power of -2 plus 1. Is that not it? According to law of indices. So I'm going to have kg ms raised to the power of -1, or kilogram meter per seconds. So the dimension here will now be mass, because I have kilogram here. This will be mass. Meter is in length. You understand? And now because I have s, that will be t. So I'm going to have over t, which can also be written as ml t raised to the power of -1. Now looking at the option, any question, any of the options, which dimension is this, will be the answer to our question. You understand? The first thing that I did here was that I first derived the dimension of impulse. You understand? The dimension is this. Are you getting it? So now, having derived this, we are going to look at the option for energy. Energy is what? Force times distance, right? That cannot be the correct option, you know. Option B, which is momentum. Impulse is change in momentum. You understand? Impulse is equals to change in momentum. And momentum, listen, momentum is equals to mass times velocity. Mass times velocity. Now, mass is in what? Kilogram. Are you getting it? And velocity is what? Meter per second. So I'm going to have here meter per second here. So because kilogram is measured in mass is measured in kilogram, I'm going to have capital letter M. Now, meter is for length, so I'm going to have L here per seconds. Now, seconds is in time. I mean, time is in seconds, so I'm going to have T here, which can also be written as what? M L t raised to the power of -1. You can see that the correct option to our question is option B, which is momentum. Momentum is the physical quantity among our option that has the same dimensions as impulse. You understand? If you check for energy, if you check for surface tension, if you check for pressure, you are not going to get this result. Do you understand? Okay, so that is the solution to that question. Okay, so for this question, option B is correct. Do you understand? Option B is the correct answer. Okay, now let us look at the next question. Which of the following consists entirely of vector quantities? Okay, we have A, velocity, magnetic flux, and reaction. B, tension, magnetic flux, and mass. C, displacement, impulse, and torque. D, work pressure, and moment. Okay, now vector quantities are quantities that have both magnitude and direction. You understand? And we want to look at the option that all the quantities there are vector. Are you getting it? So we have velocity, magnetic flux, and reaction as the first option, which is option A. Magnetic flux is a scalar quantity. Do you understand? Even though velocity and reaction are vector, but the presence of magnetic flux among that quantities disqualify the option. So the option A cannot be the correct option. Okay. Look at the second option. We have tension, magnetic flux, and mass. Magnetic flux disqualify the option as well. What of option C? Displacement, impulse, and torque. Displacement is a vector quantity. Impulse is a vector quantity. Also, torque is a vector quantity. So therefore, option C is the correct option. Okay, let us proceed to the next question. The pair of physical quantities consisting of vectors only are A. Acceleration and speed, B. Displacement and torque, C. Velocity and distance, D. Momentum and power. Okay, the correct option to this question is option B. Option B is the correct option. That is displacement, which is the shortest distance, and torque. Okay, the correct unit of energy density is A. Option A, we have this: kilogram, m raised to the power of -3, s raised to the power -2. We have the second option, m raised to the power of -1, s raised to the power -2. The third option, we have m raised to the power of 3, s raised to the power of -2. Then we have the fourth option, kilogram m raised to the power of 2, s raised to the power of -2. Okay, now energy density. Energy density is equals to energy all over volume. You understand? So here, okay, let me just put it. Energy density is equals to, now energy is what? Force times distance, right? So I'm going to have force multiplied by distance all over volume, right? Okay. Force is what? Mass times acceleration. So I'm going to have kilogram, which is for mass. Acceleration is what? Meter per second squared. So I'm going to have kgm s raised to the power -2. That is for what? Force. Now multiply by the distance. Distance is measured in meter, you know. So I'm going to have multiply by m all over. Now we have the volume. Volume is the product of length, breadth, and height, right? So, and all these three, both length, breadth, and height, they are measured in meter. So I'm going to have meter cube. Do you understand? So I'm going to have here meter cube. Okay. M times m, that is what? M squared. S raised to the power -2 multiplied by, now I'm going to take this here. So I'm going to have m raised to the power of -3. So m raised to the power of 2 plus -3 multiplied by s raised to the power -2, right? So here I'm going to have m raised to the power of -1, s raised to the power -2. So the correct unit of energy density is kilogram per meter per second squared. You understand? So let us look at the correct option. Option A is not correct. Option B is the correct option. Option B is the correct option. B is the correct option here. The correct option is this. Okay? So that is the answer to that question. Okay? Now, let us look at the next question. The dimensions of electromotive force are A. ml squared t raised to the power of -3 I raised to the power of -1. B. ml squared t raised to the power of -3 I raised to the power of -2. C. m squared lt raised to the power of 2 I raised to the power of -3. D. m squared l squared t raised to the power of -1 I raised to the power of -1. Okay, now don't forget that electromotive force is just like pressure that keep the charge moving. You understand? So, and the formula is this: electromotive force is equals to energy all over charge. You understand? This is the formula. Okay, now don't forget that energy, listen, energy is what? Force times distance from our previous question, and the unit of energy is this, right? Yes. So I'm going to have, there is no need of going through all this again. So the unit of energy, this one that you see here is for energy. So I'm just going to write it up. kgm squared s raised to the power negative 2. Okay. Now charge is measured in coulomb, you know, and one coulomb is equals to 1 AS. That is 1 amperes. You understand? So yeah, I'm going to have 1 AS. You know, are you getting it? So here, please pay attention. Electromotive force EMF is equals to, now please pay attention, kgm squared all over x squared multiplied by 1 AS. I hope you know. I'm going to explain. Okay, you see this one that you see here, kilogram meter squared per second squared is for energy, right? And it can be written as kilogram multiplied by m squared all over s raised to power 2, because the meaning of this negative 2 simply means s raised to power negative 2 simply means 1 over s squared. Are you getting it? So all this multiplied by 1 over s squared will give me this. Are you getting it? So that's how I have this. So s squared will be multiplying 1 as. Do you understand? So I've not done anything. I just want you to pay attention. Now let me erase this. Now, from this, I'm going to have EMF is equals to m raised to the power 2 all over this s squared times s. That is what? S raised to the power 3. And I'm going to have A. A is ampere. Do you understand? An ampere is measured in ampere is for current. You understand? So I'm going to have I. So kg m squared all over s raised to the power 3 multiplied by I. Are you getting it? So I'm going to rewrite this as kilogram meter squared s raised to the power negative 3 I raised to the power of negative 1. Are you getting it? Now, kilogram is measured in mass. I'm going to have m. Meter is for length. I'm going to have L raised to the power 2. S is for seconds, so that will be what? Time. T raised to the power negative 3. And I is for current, which is what? Is still high. I raised to the power negative 1. Okay? So let us look at the correct option in that question. Option A, we have ml squared T raised to the power negative 3. I raised to the power negative 1. Option A is correct. Option A is the correct option for that question. Option B is not correct. Option C is not correct. Option D also is incorrect. Okay, the values of x, y, and z respectively in the expression m to the power of x, l to the power of y, t to the power of z for the universal gravitational constant g is dash: a 2, negative 3, and negative 2; b negative 1, 3, and negative 2; c negative 1, 2, and negative 3; d negative 2, negative 1, and 3. Okay, don't forget that universal gravitational constant G equals to 6.674 times 10 raised to the power of negative 11, yes, negative 11 Newton meter squared per kilogram squared, right? This is it, right? Now listen to me carefully. M raised to the power of x, they give us this, L raised to the power of y, and T raised to the power of z. We are asked to find the value of x, y, and z that suits this constant. Are you getting it? Now, do you know that Newton is in force? Are you getting it? The unit of force is Newton, right? And force is the product of mass and acceleration, right? And mass is in kilograms. So I'm going to have kilogram, and acceleration is what? Meter per second squared. So I'm going to have meter per second squared. Okay? Now, it is this unit. I'm going to replace this n as kilogram meter per second squared. Do you understand? So here I'm going to have, instead of Newton, I'm going to have kilogram meter all over s raised to the power of 2 multiplied by m squared times m squared divided by kilogram squared. Do you understand? Okay, m times m, that is what? M raised to the power of 3. So I'm going to have kilogram m raised to the power of 3 multiplied by 1 over kilogram squared, right? Do you understand? Because now this is division. Do you get it? So please pay attention. Don't forget the s raised to power 2. Now for this, I'm going to have, bring both x squared and kilogram squared, bring it up. I'm going to have kilogram meter cube multiplied by s raised to power negative 2 and kilogram raised to power negative 2, right? So here, this will multiply this. I'm going to have kilogram 1 plus minus 2 meter raised to the power of 3 s raised to the power of negative 2. Do you understand? So for this, 1 plus minus 2 is what? Minus 1. So I'm going to have kg raised to the power of minus 1 m raised to the power of 3 and s raised to the power of negative 2, okay? Now, kilogram is for mass, you understand? So I'm going to have, instead, I'm going to have capital letter M. Meter is for length. I'm going to have L raised to power minus 1. This one raised to power 3. And seconds is for time. I'm going to have T raised to the power of negative 2. So now, the value of x here will be negative 1. This one will be 3. And T will be what? Negative 2. The value of x is negative 1. Y is 3 and Z is negative 2. So the correct option is option B. Option B is correct. Option B is the correct option. Do you understand? Okay, so let us look at the next question. In order to remove error of parallax when taking measurement with a meter rule, the eye should be focused A. Slanting towards the left on the markings. B. Slanting towards the right on the markings. C. Vertically downward on the markings. D. Vertically upwards on the markings. Okay. Now, in an attempt to avoid error due to parallax, your eye, when taking measurement with a meter rule, your eye should be positioned in such a way that the line of sight is perpendicular to the markings on the meter rule. Do you understand? So the correct option is option C. That is vertically downward on the markings. Do you understand? Okay, so option C is correct for this question. Option C is correct. Vertically downward on the meter rule. Okay, so let's look at the next question here. The pair of physical quantities that are scalar only are A. Volume and area, B. Moment and momentum, C. Length and displacement, D. Impulse and time. Okay, now if you look at the first option there, volume and area, volume is a scalar quantity. Likewise, area is a scalar quantity. So therefore, the correct option is option A. For that question, option A is correct. Volume and area, both of them, they have magnitude. You understand? Like they have measurement, they have magnitude, they have size, but they didn't have direction. So these quantities are the scalar quantities there. If you look at the second option, momentum is a scalar, is a vector quantity. Displacement is a vector quantity in the third option, and impulse is a vector quantity in the fourth option. So the correct option is option A, which is volume and area. Okay. Now let's look at the next question. A quantity which requires magnitude and direction to be specified is dash. A. Distance, B. Displacement, C. Mass, D. Temperature. Quantities that require magnitude and direction to be specified are called vector quantity, right? Yes. Now, among this option, which one is the vector quantity there? Distance is a scalar quantity. Okay. Displacement is a vector quantity. That is the shortest distance traveled by an object. So the correct option to that question is option B. Option B is correct. Displacement. Displacement. Okay. Okay, let's look at the next question. I represent electric potential. I represent electrical potential. And I represent torque. Okay. Roman figure 3 represents kinetic energy. Kinetic energy. And the fourth, we have momentum. Now, the question is, which of the quantities listed above, listed on the board, are vectors quantity? Okay, vector quantity have both magnitude and direction. That is, they have size and also they also have a specified direction. Now, electric potential is a scalar quantity. Okay, kindly note that. From our previous class, I told you electric potential is a scalar quantity. Torque is a vector quantity. Vector. Kinetic energy is a scalar quantity. Scalar. Momentum is a vector quantity. So the vector quantity that we have here are torque and momentum. That is II and IV. Do you understand? So the correct option is option D, which is II and IV. Option D is correct. Okay. Let us look at the next question. The dimension of work and energy are A, ml squared t raised to the power negative 3, B, ml t raised to the power negative 1, C, ml squared t raised to the power negative 2, D, mlt raised to the power of negative 3. Okay, now don't forget that work and energy. Work is equals to force multiplied by distance, right? Also, energy is equals to force multiplied by distance. Now, force is measured in Newton, do you know? So I'm going to have, and Newton is what? Kilogram meter per second squared multiplied by distance. Distance is measured in meters, so I'm going to have multiplied by m. Do you understand? Okay, so here I'm going to have kilogram m times m. That is what? M squared, s raised to the power of negative 2, right? Now, kilogram is for mass, so I'm going to have capital letter M. For meter, I'm going to have length, L raised to the power 2. And for seconds, I'm going to have time, you understand? So I'm going to have t raised to the power negative 2. So the correct option is ml squared t raised to the power negative 2. That is option C, ml squared t raised to the power negative 2. Option C is correct, okay? Option C is the correct option. Okay, let's look at the next question. The dimension of power is A, ml squared t raised to the power negative 3, B, ml raised to the power 4 t raised to the power negative 1, C, ml t raised to the power negative 2, D, mlt raised to the power negative 3. Okay, let's look at it. Power is equals to power is the time rate of doing work, right? So that will be what? Work all over time. Okay, now work is what? Force times distance. Do you know? Please listen. Work is force times distance. So the unit is what? Kilogram meter squared per second squared, right? So here I'm going to have kilogram meter squared, a meter squared per second squared divided by time. The unit of time is what? Seconds. So I'm going to have divided by s. Are you getting it? So here I'm going to have kilogram meter squared s raised to the power of minus 2 multiplied by s raised to the power negative 1. Do you understand? So here I'm going to have kilogram meter squared s raised to the power negative 2 plus minus 1. That is what? Minus 1. Minus 2 minus 1. That is what? Minus 3. So here I'm going to have kilogram m squared s raised to the power of negative 3. Okay. Now kilogram is for mass. Okay. Meter is for length. And seconds is for time. So put the power. This will be square and this will be minus 3. So the correct option is ml squared t raised to the power negative 3. ml squared t raised to the power negative 3. The correct option is option A. Option A is correct. Option A is correct. ml squared t raised to the power of negative 3. Okay, now, okay, let us look at the next question. Which of the following is the dimension of pressure? A, ml raised to the power negative 1, B, mlt raised to the power negative 2, C, ml squared t raised to the power 3, D, ml raised to the power of negative 3. Okay, don't forget that pressure is equals to force over area, right? Pressure is force per unit area. Do you understand? And force is measured in Newton, right? So that would be what? Kilogram meter per second squared, right? Because force is what? Mass times acceleration. Kilogram stands for mass, and acceleration is what? Meter per second squared. And this over, now area is what? Length times breadth, that is what? Meter squared. So I'm going to have m squared. Okay, kilogram, m s raised to power negative 2 times m raised to power negative 2, because if you bring this up here, you're going to have negative 2 as the power of m. So multiply this and this together. I'm going to have kilogram meter raised to power 1 plus minus 2 s raised to power negative 2, okay? M raised to the power of negative 1, s raised to power negative 2. Okay, kilogram is for mass, meter is for length, and seconds is for time. So this is what? Minus 1 and what? Minus 2. So therefore, the correct answer is ml raised to power negative 1, t raised to power negative 2. Let us look at the correct option. Yeah, among this option, there is no correct option, okay? This is the correct answer to the question, okay? So we've come to the end of this class, okay? If you have any question as touching what we've discussed in this class, let me know in the comment section, okay? And also, don't forget to hit the like button, subscribe to the channel, share the video to your friends. And in addition to this, if you missed the previous class, you can check the links in the description of this video, okay? See you in the next class.